All right. Good morning, my amazing class.
Good morning, my amazing teacher.
So we are starting day 2 of boot camp. So yesterday we ended with going over histograms, and I wanted to show you a possible question. Y'all got lucky on benchmark 3. They did not give you this question. Every year they give this question, and it's always most missed. So I want to go over it just in case it would have been y'all's most missed. Was this your most missed? No, but it could have been. You just didn't have a problem like this. So let's talk about this. It says a student records the heights of classmates in centimeters. The histogram represents the what? Data. So remember, what did we say a histogram only shows you? Only shows shape. So it only shows shape. Well, what is something that you can see now that you know it only shows shape? What's some ways that we can describe this?
It's skewed right.
Okay. So think about the peak. You ready? Which way does it stretch out more? Does it stretch out more going one way to the other, or is it pretty much the same?
Same.
From the peak, it's pretty much the same. I would say this is symmetrical. Because remember, it doesn't have to be perfect. It doesn't have to be exact. If we had more, don't draw this. Don't draw this, okay? Do not draw this. But if we had it doing something like this, and even if it went higher one more time, where do you think that data would be stretching out farther to? Left. So then that would be skewed what? Left. But our data is actually pretty what? What else could I describe data as? Having clusters. Okay. And what's the clusters?
137 to 151.
That's right. What else? Bless you.
Outliers.
Outliers. So does it have an outlier?
No.
No, it's not out there all by itself. Okay. And that means it has to be one number out there by itself. Okay. Peaks. I agree. Whoever said it. Good job. Peaks.
143 to 145.
That's right. And then gaps. Were there any gaps? No. All right. So that's how we describe the shape of the data for a histogram. And a histogram only tells you that. But then they decided to make it a higher ordered thinking question. They decided to make it a higher order thinking question by going, what could be a possible data set that describes this? Well, look at our first category. Well, it's 137 to 139. How many numbers do I need from 137 to 139?
One.
Well, looking at A, how many numbers do they have from 137 to 139?
One.
So that's a possible answer choice. Looking at B, how many is 137 to 139? One. Looking at C,
Two.
2. Circle them, group them together. Now, is C an answer?
No.
No. Okay. So, what about D? All right. So, is D an answer choice? All right. So, when I'm looking at this, I got rid of what?
C and D.
C and D. Now, when I'm looking at my next category, how many numbers am I looking for in my next category?
3.
Well, does it have 3 numbers ranging from 140 to 142?
No, it has 4.
I agree. So could that be an answer?
No. B.
So obviously B is my answer, but let's double check. Let's practice grouping it like this. You ready? So B is 140 to 100. Whoop, I almost messed up. 142. That's your first group, second group. And then my third category, how many numbers do I need?
4. 2.
So how many does it have? 4. My next category, 146 to 148, how many numbers?
2.
149 to 151, how many numbers? Okay, so is that true? So B is my answer. So before we moved on from histograms, I did want to make sure I did show you this as a possible question, okay? And the kiddos discussed last year that they had a question like this on their end of the year test, okay? So just be careful, make sure you are studying a possible question like this. So what you'll do is you'll staple this to the back of the packet at the end of class. So we're going to move on with number 6. So 6, it says the table shows the number of hours per week that each of the 13 7th grade students spent doing homework. Create a box plot to summarize the data. First of all, what's another word for box plot? Box and what? Whisker. Well, to remind you about this box and whisker plot, we have to know our 5-number summary. We have to know what's our minimum, what's Q1, what's Q2, and what's Q3, and what's our maximum. So we are going to have to determine, again, what's our minimum, what's our Q1, our Q2, our Q3, and what's our maximum. So when I'm looking at this, what do I need to do before I even begin? Put my data from least to. So I'm going to have a 3, 4, 5, 5, and now I'm lost. What should I do better? Cross it out when I find it, because good thing I did. There's actually another what? 5. Alright, there's not a 6. I got 1 7, I believe. No 8s. 1 9. 1 10. 3 11s. And 2 12s. Now, box and whisker plots are technically on number lines. Box and whisker plots are technically on what? Number lines. But I told you you can do it just by writing out your data to know where these numbers are going to go. Okay? So when I'm looking at this, I first need to identify my what? My what? Median. Find your median. Do the rainbow. Find your median. Thumbs up once you have the median. What's my median?
9.
So my median can also be called Q. It's 9. So I'm going to come over here and write it down. What's the next thing I need to determine?
Q1 and 2.
That's Q1 and what? 3. So I like, when I do have an exact middle number, I like to put my pencil over it so I can see the lower half and I can see the upper what? Half. I can see the lower half and I can see the what? Upper half. So when I'm looking at my lower half, how many numbers do I have in that lower half? So am I going to have an exact middle there since it's an even amount of numbers? No, where's that exact middle going to be in between? 5 and 5, the first 5 and the second 5. So it's in between that first 5 and that second 5. So what do I need to do with those two 5s to find the exact middle?
Add them all and divide by 2, so that's 5.
5 plus 5, yeah. And that's the trick. 5 plus 5, 10. 10 divided by 2 is 5. So, yes, because they're the same number, it is obviously going to be 5. Now, looking at that upper half of the data. That upper half of the what?
11.
Okay. So, which 11s?
Those
Is it just one 11 that's my perfect middle?
the second and the third one.
The second 11 and the third 11, there's a perfect middle in between there. And that would be Q3. And what's it going to be? 11 plus 11, 22. 22 divided by 2 is 11. Yes, it's the same number, so we can just put 11. Okay? So, let me come over here and write down my data. What you have done when you identified the end of Q1 and the end of Q3, you have determined the box. The box is split into 2 parts. Well, I got the box part of my plot. What do I need now? And what determines my whiskers?
The minimum and maximum.
What's my minimum?
3.
What's my max?
12.
So I put my whiskers on 3 and 12 and I draw my whiskers. Okay? So when I'm looking at this, that's how you create a box and whisker plot. A box and whisker plot, it's actually on a number line. And if you look down at number 8, do you see 3 box and whisker plots on one number line?
No.
If you look down at number 8,
Yes.
do you see 3 box and whisker plots? Those are technically on a number line, but I asked you to create it just like this to make it easier on you, okay? When you have box and whisker plots, you can only determine 3 data points. You can only determine 3 data points. The data points you only can find are the median, the range, and the IQR. The median is what? You already found it.
9.
Thank you. What's my range? How do we find range?
Q minus max minus.
And then what's it going to be? 12 minus 3. We already found them. Is what?
9.
All right. And what's my IQR? What do I do to find IQR?
Q3 minus Q1 equals 6.
All right. Q3 minus Q1 would be 11 minus 5, and you get? So a box and whisker tells you median, range, and IQR. It can tell you if it's symmetrical or if it's skewed, but you have to see it on a number line. Is this on a number line? Is this on a number line? No. And we'll look at on the back of this paper, we'll look at a box and whisker plot that's skewed, okay? But not right now. We'll worry about shape later on with a box and whisker. Get it? Got it? All right, so now looking at 7. In history class, Hans' homework scores are 100, 100, 100, 100, 95, 100, 90, 100, and a what?
0.
Oh, man. Oh, man, he had how many 100s?
5.
6.
6.
Man. Then 95, which is still an A, and then he had a 90, which is a B. But then he ended up obviously not doing a homework lesson. It happens, right? Okay. The history teacher uses the mean to calculate the grade for homework. What's the mean?
Add them all up and divide by.
That's right. What's another word for mean?
Typical average.
Average. So he found the average. And it says, write an argument for Han to explain why median would be better measure to use for his homework grades. So we need to find the mean and the median. So let's first put our data from least to greatest. We're going to have a 0, we're going to have a 90, a 95, and how many 100s did we say? 1, 2, 3, 4, 5, and 6. So I want you to find the mean and the median and give me a thumbs up once you have the mean and the median. So once you add all those numbers up and you divide by 9,
87.2 would be 87.2.
you get 87.2.
Repeat.
So put your hat on it. Now, anybody round it? Because in the real world, in class, in Miss Jones's class, what do? We what? We round. Let's round it. What does it round to?
87.
It rounds to 87. Okay, so let's round 87.2. Remember, 5 or more, raise the score. 4 or less, let it rest. So what does it round to? 87. What was the median?
100.
Okay. Write an argument for Han to explain why the median would be better measure to use for homework. Why is the median better? It gives you a what?
Higher score.
It's a higher what?
Score.
Do I need you to write an argument? No, we worked it out. I already know y'all like to argue. It's all right. I already know. Just justify that it's a higher what?
Score.
But I do want to tell you this. Miss Jones, if you're normally making 100s and 90s, and then out of nowhere you make a 0, it's either because you forgot your homework or something happened that night. Real world, I understand that. And you make a 0, I'll put it in the grade book, but I usually give you the opportunity to make it, or I drop your lowest grade. Huh. How many of you had the idea of 87's not that bad? It's not. But you could have been what? Way higher. Let's. Thank you. Have a great day. Love you. Bye. Okay. Class.
Yes.
When we start getting that mindset of, yeah, I made a 0, 87's not that bad, it's still a B. You get that mindset, you're going to have that mindset again. Guess what? What happens if you have that mindset of 87's not that bad? What do you think you're going to make again?
An 87. When you could have been higher.
What made you have that 87?
0.
Okay. So, if you have that mindset, what do you think you're going to get again?
0.
A 0. Because that's true. That if you get that mindset, it's true. I want y'all to write down another data set of, you forgot one homework again. So now not only do you have 1 0, what do you have?
2 zeros.
So we just added a what?
0.
We just added a what?
0.
0. We added a data point. We added a 0. Find the mean and the median when that happens. What's the mean?
100.
What's the mean?
78.5. 79.
And it rounds to a 70. Okay. Well,
Is that a C?
yeah. But think about it.
He could have done that too.
You were scoring in 90s and a lot of 100s. And 1 0 dropped it down automatically to a low B. Uh-oh, you made another 0. It dropped it down to a C, right? Okay, what's the median still, though?
100.
What happened? It stayed the...
Same.
All right, well, in a perfect world, your teachers completely understand that it was rough, didn't get your homework done. Drop those 0s. Drop them. Drop them. Find the mean and the median. What do you get for your mean?
98.125.
So we'll just say 98.1. What does that round to?
98.
What's the median?
100.
If you never made that 0, hocus pocus. It's just a dirt dauber. We're going to survive. It's fine. Hocus pocus. If he never would have made that 0, what average would he have had? An A. He would have had an A. He made 1 0, dropped it down to a B. You make another 0, it drops it down to a... And that's just homework grades. Are we even talking about test grades? Test grades can't weigh more. So if you are not a strong testing student, what's happening?
Your average will go down.
Your average is probably going to go down even more than that 79 with those 0s, okay? So what stayed the same all the way through?
Median.
Why would Han want to have the median as his average? It's higher score. Is it fair? No. And it's really not fair in a scenario of the median was, say, pretend the median was a 90, but your average is a 98. Would you want to go by that median of 90? No, you want your average. You want to be fair. You want to be truthful with your data. So you don't have to get it out. But I want to point out to you that we just worked out these memorization here. Data is symmetrical when the mean and the median are the same. Well, look at our mean and our median. Is it the exact same? No, but they're close together. So this would be symmetrical. If we drew it out on a graph, it would be symmetrical because the mean and the median are the same. Are the mean and the median the same on these two? Are the mean and the median the same on these two? No, they're pretty far off from each other, right? So they're most likely going to be skewed. And you should be able to tell me, not only is it skewed, but what is a 0 compared to all of these numbers? What is a 0? It's out there all by itself. It's your what? Well, if it's skewed or has an outlier, what's your best measure of center? You definitely would love to have that median, which was 100 every single time, right? Yeah. When your best measure of center is symmetrical and you don't have an outlier, which one would you rather have? Mean. Okay? So, extreme outliers, those zeros, have a direct effect on the mean and the it didn't have an effect on the median. The median stayed the same. Extreme outliers have a direct effect on the mean and range. We only talked about the mean. In a little bit we'll talk about range. Okay? If you add a 0 or even a 100, is it going to change your average? Yes. If you remove a 0, is it going to change your average? Whatever you're doing, I need you to stop. You're distracting your classmates. Some of them have already told you to stop. If you add or remove a number from the data, it could change the measures of center and variability. Does it change all measures of center? No. What stayed the same on our work earlier? What else would have stayed the same? Think about another measure of center. We've talked about mean, median. What's the other measure of center? Mode. What would our mode have been? 100. Would it have changed it? No. So the main measure of center, that if you add or remove data, the one that's going to change every single time, and that's fair, and that's what your teachers go by, is your mean. It's your average. It's your typical. It's your general. Get it? Got it? Okay. So that is it on that problem. Now let's look at 8. And I love 8 because we're about to go by this super fast, because did it ask you to create a box and whisker plot? No, it's asking you to read it because they already have the box and whisker plot. Here, what do you get from a box and whisker plot? You get your minimum, you get your Q1, your Q2, your Q3, and your maximum. Remember, your Q2 is also called your median. I want you to label with me, because I want us to estimate these box and whisker plots. And what I mean by estimate, I want us to do it to the nearest half or whole. And because some of these markings are in between the half and the whole, and can we really see what number it would be? So we're going to estimate it to the half or the whole. So looking at crate 1, what's our minimum? Look at where that minimum lines up at. It's almost on 1 point what? It's in between 1 and 2. What's in between? 1.5. What's that as a decimal? We like decimals better than fractions. It's 1.5. Look at the Beginning of the box. What's the beginning of the box called?
Q1.
Q1. And it's about on what number? I would say 3. It's closer to 3 than 3.5. Okay, is it perfect? They shouldn't do this to you on the test. It will be perfectly lined up on a marking. Okay, so it's 3. Look at Q2. It's close to what whole number?
4.
Look at the end of our box. Is Q3. What is it on? It's on 4.5. And then our maximum number is on what?
6.
And again, that was for crate what? 1. I'm going to underline it so I know that's for crate what? 1. Go ahead and do crate 2 and 3. Go ahead and do crate 2 and 3. Finding that min, that Q1, that Q2, that Q3, that maximum. Don't you love it when they already give you a box and whisker plot? Because all you got to do is just write down the points. Quickly, let's go. So crate 2, my minimum is probably going to be a 0 point. It's either a half or a whole. It's 0 point. I'd say it's closer to 0.5. And then, what's Q1 going to be? 1 point what? And then what's Q2 going to be? What's Q3 going to be? I say it's closer to 2.5. What is the maximum going to be? I say it's closer to 3.5. So I did crate 2. Crate 3. What do y'all say it's closer to? 2.5 or 3?
2.5.
It's closer to 2.5. Q1 is closer to, and then 4, and then, so do we need to look back at this anymore? What does minimum, maximum, Q1, Q2, and Q3 help me determine? The what? I agree. It tells me my IQR. What else does it tell me? I need to write that higher. I'm going to mess this up. Let me write that higher. It tells us our IQR. It tells us our range. What else does it tell us? Median. And that's it, right? Can we see the mode? Can we see the mean? Okay. We don't know the data set, so we can't see the mean and the mode. So looking at crate 1, my IQR is Q3 minus Q1. 4.5 minus 3. 4.5 minus 3. My range would be max minus min. 6 minus 1 point.
4.5.
And you get? And then if I look at my median, we already found our median. Our median is Q what? 2. Well, what was our median for crate 1?
4.
All right, well, I did crate 1. Let me do crate 2. What's your IQR for crate 2? 1. What's your range?
3. Wait.
Max minus min. 3.5 minus 0.5 is?
3.
What's our median?
2.
Y'all know what you need to do? Y'all got it? What does IQR mean to do?
Q3 minus Q1.
Look at your Q3. What's your Q1? 4.5 minus 3.5 is?
1.
Range, max minus min. Subtract it. 5 minus 2.5. 2.5. And what was the median? Do you have to do any work for it? You just look. What's your median? Now we have all the answers to all the possible questions here that I can just look at my table, either one of these tables, okay? So it says select all the statements that are true according to the box plots. The weights of the pineapples in crate 1 were most variable. Most variable. Key words for most variable that match up with variable is either range or enter. Most means which one has a higher variability. Which one has a higher variability? Which one has a higher range, a higher IQR? What crate has a higher range, a higher IQR? What crate? Look at your table that we made. What crate has a higher range and a IQR? Crate what? Is that true? The heaviest pineapple was in crate 1. What's another word for heaviest? Max. Biggest. Okay. Did we find our maximum? Which one is the heaviest pineapple? You can look at the box and whisker, or you can look at what we drew out. Is it true? The lightest pineapple. What's another word for lightest? Minimum. It was in crate 1. Looking at this, the minimum of crate 1 ends here. I can see that obviously which one? Crate 2. Because it was 0.5. So I'm going to change that to crate 2 and justify why it's not our answer. Crate 3 had the greatest median weight. Median is Q2. Crate 3 had the greatest median weight. Did crate 3 have the greatest median weight?
No.
It could be. Hold up. It is the highest, but there's another one that's the what?
Crate 1.
Highest. Oh, I need to keep on reading. It also has the highest IQR. Does crate 3 have the highest IQR? No. What had the highest IQR? So this is not true because it's crate 1. It would have been true if it would have said the IQR was in the middle. So more than half of the data, more than half. How much is that as a percentage? More than half. 50%. All right. So we need to look at our 50% mark. We need to look at our 50% mark. What's the 50% mark? What's the half called? Thank you. So also we can look at our 50% mark. Our 50% mark is our median, is our Q2. More than half of the pineapples in crate 1 and crate 3. What's our half mark for crate 1 and crate 3? They included those because they are the
Biggest.
Not because they're the biggest, they're the same. Okay? So 50% of the pineapples in crate 1 and 3, they were the same, are heavier than the heaviest pineapple. What's another word for heaviest pineapple? What's the maximum pineapple in crate 2? What was the maximum pineapple in crate 2? What's the maximum pineapple in crate 2? Is 4 heavier than 3.5? Is 4 heavier than 3.5? So what else is my answer? That one, right? So A, B, and E. I'm breaking these down slowly so you know how to solve this one. This is in a lot of detail. Okay? This is harder than what it should be on your test. Do you understand? But if you can understand this, you're definitely going to think the test is easier. Get it? Got it? Okay, so turning our paper over. Nine, 10, and 11 it's going to fly through because we already know what we're doing. Priya asked each of 5 friends to attempt to throw a a ball in a trash can until they succeeded. She recorded the number of unsuccessful attempts made by each friend. Priya made a mistake that the 8 in the first data set should have been a what? 18. And how would changing the 8 to the 18 affect the mean and the median of the data set? We already know from working it out last time when we were talking about grades, if you change a number from an 8 to an 18, that 18 went up, right? So your average should go, but what usually stays the same? The median. We're going to work it out to explain it. We're going to work it out to what? Explain it. So what we have to do is for the first data, so data set 1, what was our first data? 1, 8, 6, 2, and 4. Put it from least to greatest. So I believe it's going to be 1, 2, 4, 6, and 8. I want you, for the first data, to find the mean and the median. But because it's small numbers, these are measures of center, right? I want you to find one measure of variability. Which measure of variability do you think I want us to find? I don't want us to spend a lot of time. Range. I want you to also find range. So these are our centers. And this is our variability. It didn't ask us to, but I want you to see something since it's easy numbers. Okay, these are easy numbers. I want you to see something for me. So find that mean, median, and range for that small amount of data. Once you have that, thumbs up. What's my mean?
21. 4.2. 4.5.
Okay, try again. This is small numbers. Add it up and divide by how many numbers?
Oh, I forgot to divide. 4.2.
Thank you. You're still cool.
I forgot to divide.
It's okay, you're still cool. Ah! All right. What's my median? You really don't have to draw the rainbow for this one. You should be able to see the middle.
4.
What's my range?
7.
8 minus 1 is?
7.
Okay. She messed up when she was trying to figure out how long it took her friend to make the shot. It didn't take that friend 8 shots. How many shots did it finally take her to make?
18.
Woo! We got to do a data set too. Change that 8 to a what?
18.
Ooh, I didn't put a comma there. That would have been terrible. Sorry. All right. I want you to find the same thing. Find the mean, find the median, find the range. Get it? Got it?
Yeah.
Mean and median are centers. Range is variability. He gonna turn around and get you. What's my mean?
0.2.
What's my median?
4.
What's my range?
17.
What changed from data 1 to data 2? The mean. What else?
And the range.
What stayed the same?
Median.
So before we answer A, B, C, or D, you don't have to get it out, but you have it out on your desk. You look at the back on that memorization. You listening? If you add or remove or even just change a number, if you add or remove or even just what? What's most likely going to change? I heard the wrong thing. Mean and what? Range. So if you add, remove, or change anything in a data set, it's going to change your mean and, but what's going to stay the same? Median. It will most likely stay the same. So also, data is symmetrical when the mean and the median are the same or close together. Which data would be symmetrical? Data 1 or data 2? Data what? 1. Because the mean and the median are only how far apart? 0.2, right? 2/10. They're 2/10 apart, okay? So data 1 is symmetrical. Data 2, that mean and that median are far off compared to data what? 1. What does that mean data 2 is going to be? Skewed. But there's a main reason why it's skewed. There's this main reason why it's definitely skewed. You didn't even have to look between this. Look at the data. There's a number that's oh so lonely. What's out there all by itself? What's out there all by itself? What is 18 called? And because the data has an outlier, it is skewed. It's stretched out there. Think about it on a number line. 18 is stretched out there all the way on the
Right side.
okay. So again, looking back at this, the best measure of center when it's skewed would be what? Median, because it basically stays the best measure of variability would be IQR, because it's talking about the inside of the data. But if your data is symmetrical, like how it should be in class when you're getting grades, your data should be symmetrical. Should you be having a 0? No. So what should your teacher take? The mean, because it's fair, right? You would want me to take that median that was 100 last time, huh? But what would be fair? The mean, if your data is symmetrical. And then the range would be fair because it's true. Where's your grades ranging from? Well, think about, was it Hans? I think that was the name. If you think about Hans's grades, he ranged from a 90 to a 1. So 100 minus 90 was 10. But then he made a 0. Do you want me to take that range? He went from 0 to a 100. 100 minus 0 is 100. You want me to take that range? Does Han truly make 0 to 100s? No, he truly makes 90 to what? Okay. See why we're going in detail? Doesn't the memorization make a little bit more sense now? Okay. All right. So moving on. Plots tell you. Woo! Look at y'all go. We are going to have a part of bell work tomorrow. On bell work tomorrow for 10, you are going to find the IQR. For bell work tomorrow, you are going to find the IQR. But I'm ready to be done with today's lesson, aren't you? We're almost up to an hour. And I don't like having an hour lesson. Okay? So we are not going to find IQR because it takes a little bit of time. But I do want you to find everything else. Okay? The mean, the median. What else? What's the other measures of center? And what's our measure of variabilities? We're just finding range. You can write down IQR and put an equal sign, but are you finding it right now? No. You find it for bell work too? Okay. And then what else did you learn that data can tell you? It tells you the what?
Shape.
Tells you the shape. So I want you to describe all these things, just mean, median, mode, range, and the shape. Thumbs up once you have it. I'm pausing the video, but thumbs up once you have it. So work on finding the center, the variability, and the shape. All right. So what I have already done, and what you should already have done, you should have everything done, but I just wrote out the data set from least to greatest. Again, you were finding the mean, median, mode, and range. Tomorrow's bell work is going to be the IQR. I left space for you to be able to do the IQR tomorrow for bell work right here. So tomorrow for bell work, your IQR needs to be worked out in this location. Get it? Got it? And don't forget to answer it. Get it? Got it? And we're also going to talk about the shape. Now, there's one thing I did not write down with shape that we can't write down yet, and is it skewed or symmetrical? So we'll get there. Get it? Got it? So, what is my mean going to be once I add all the data and divide by that amount of data points? The amount of numbers. What's my mean going to be? 4.1. Okay, so if you didn't get it, just put a mark by it so you can go back and double check, okay? All right, so if you didn't get it, put a mark by it like that if you didn't get it, and you can go back and double check in a little bit. Median, what's your median going to be?
3.
Mode?
2 and 3.
2 and 3. Range? Now, looking at our shape, do we have any clusters?
Yes. 2 through 5.
2 through 5 and
8 and 9.
8 through 9. That's right. Gaps.
6 and 7.
So you can write 6 and 7, or you can write 6 through 7.
I just wrote 6.
Now, an outlier is only 1 point out there all by itself. And
I have 0 outline.
so, no, don't say 0, because 0 could be a number. So, no outliers. Same thing as mode. Don't say 0, right? No. Okay. You're still cool. I'm glad you said it. All right. Peak, highest point.
2 and 3. 2 and 3.
And then there's one way we can describe the shape of this data, and that is by seeing where the tail, how it's tailing, which way is that tail stretching out more to, seeing which way that tail is stretching out to. Wah!
Right.
This is all video and you're gonna drive me crazy. Focus, we're almost done. I'm losing y'all, but please focus. Which way is that tail stretching out to?
Right.
To the what? Right. So this is skewed,
Right.
or you can say tailed.
Right.
You're going to be the chosen one to stay in for break. Flat tire. No. If I got to pause this video one more time to get y'all's lives together, it's not going to be good. Rule number 4. Rule number 4.
Make smart choices.
Thank you. You're welcome. Thank you.
You're welcome.
What do we have on the final one? What is this?
Box and whiskers plot.
It's a box and whisker plot. A box and whisker plot only tells you a few things.
Only tells you.
Okay? Well, we're going to about it. But a box and whisker plot tells you a 5-number survey. Summary. Survey. Haha. Summary. The minimum. The maximum. What's in between the minimum and maximum? The Q1.
Q1, Q2, Q3.
And they gave you small numbers to make your life so much easier. What's the minimum?
2.
Yep, right there. What's the maximum?
15.
Man. What's Q1? It's in between 4 and 6.
5.
And then our Q2 is that line in the middle of the box.
6.
And
10.
then I just got to answer the questions.
15.
This is the perfect world for a box and whisker plot, y'all. What is the greatest number? Another word for greatest number is?
Maximum.
It could say heaviest. Matters on the scenario. So what is it?
15.
The median. What's another word for median?
Middle. Q2.
Or it could say 50%. Read by the students. What is it?
Six.
Oh, Lord. Thank you. All right. What is the interquartile range? Q3 minus Q1. What do you get?
5.
Now, add a letter D. What is the spread? Spread that butter on that bread. And that means... There it is. What is the spread? What's another word for spread? Spread could also mean IQR, but it would have talked about the inner spread. It would have said something about the inside, okay? So, what is the spread? What is the range? That's max minus min. What's max minus min?
13.
So, 15 minus 2 is 13. Now, we only are going to write one more thing and then talk about another thing, okay? We're only writing one more thing. Normally, they talk about skewed data or symmetrical data. Your words. Skewed or symmetrical is usually seen on histograms or dot plots. Mirrors off. If we look at this is a box and whisker. To determine if it's skewed or symmetrical, you look for the longest whisker, or if they're the same. This one has a longer whisker. This one has a longer what?
Whisker.
Which side is the longer whisker?
Right.
The right. So it's letter E. It's skewed.
Right.
For the longer.
Can't see.
Oop, skewed right because of the longer what? Meow. The longer what?
Whisker.
Whisker. Okay, because of the longer what?
Whisker.
It's skewed right because of the longer
Whisker.
whisker. So if you will you please look back at 8? And we're going to practice, is it symmetrical or is it skewed? And then we're done. Okay. All right. So once you have that written, look back at 8 real quick. You don't have to write it down. I just want you to tell me. Look at the whiskers on crate 1. Ooh, where are you, crate 1? There you are. They're about the what?
Same.
So that's pretty what? I'm going to put seal. What about crate 2? That's pretty. But crate 3, skewed left. Did that take long? Your homework is to study this packet. Do not forget to be studying your geometry formulas that you've had since Christmas.
Yes, ma'am.
Okay. Quietly and appropriately say goodbye.
Goodbye.
Have a great day.